Hi, good evening. This is my first video for 4th grade math, and I am just going to work through all 12 problems from the study guide, just so if students want, they can work the study guide along with me. Alright, so number 1, it says the table below shows the 3-point field goals made by 3 basketball players during the 2001 NCAA basketball season. And then at the bottom it wants us to write Tevis Stooks' average number of goals in words. So that's important because we're going to have to be able to do this in words. So if I look at the chart of information that they give me, I've got 3 different basketball players here, and then the average goals per game. And it's written out in base 10 model, and it shows me that one of these equals a whole. So I am looking for Tevis Stooks, so I'm going to come find Tevis, and I'm just going to put a little star next to him because that's the one that I'm looking for. So I'm going to count this up, so I have 1, 2, 3 holes. Okay, so 3 ones, and so if I look here at this next base 10 block, I can see that I don't have a hole, but I do have some tenths filled in. So I have 1, 2, 3, 4 tenths filled in. So I'm going to put 4 tenths. And then if I look here, I have some hundredths. So I have 1, 2, 3, 4, 5 hundredths. So I have 3 and 45 hundredths. Now, the question asks me, if I go back and look at it one more time, it says to write the average number of goals in words. So I couldn't write this because that's standard form. So I have to change the standard form into a new representation, into word form. So I'm going to write 3 and 45 hundredths. So this is how we changed. Remember, I got that this at the end. Alright. Question number 2. In the numbers shown, 1 digit is underlined and 1 digit is circled. So if I look at this, I want to ask myself, okay, this is the 10,000s and this is the thousands place. So 1 is underlined and 1 is circled. So let's look. Which statement is about the circled digit is true? So I'm looking at the thousands place, the 7 in the thousands place. I'm going to ask my question first. I'm thinking about this. Well, I know that when I was circling and underlining digits, we were talking about 10 times or 1/10 of a value. So if I'm thinking about this circle digit in comparison to this underlined digit, I know this one's smaller. So I know this is probably 1/10 of the 7 in the 10,000s. So now let's go look at my answer choices. It says its value, and remember its here is the circled digit. So its value is 10 times greater than the value of the underlined digit. No, I don't think so, right? Because I just said that this one is actually smaller. It's worth less because this is in the thousands place. So I know that it's not that one. Its value is 1/10, and sometimes you're going to see it written on the test in words, not in a fraction. So its value is 1/10 the value of the underlined digit. Oh, I think that's what I was saying earlier. But let me read the other questions just to see. Its value is 70 times the value of the underlined digit. Oh no, we know that's not right because we know it's either going to be 10 times or 1/10. Its value is 1/70th the value of the, oh, well, we know right away it can't be that one. So my thinking was correct. Since the circled digit is in the thousands place and the underlined digit is in the 10,000s, I know that this 7 is 7,000, right? The circled digit is 7,000. And the value of the 7 in the 10,000s is 70,000. So this is less than that one. So definitely G is the answer. 3. Lillian paid $61.39 for groceries. The digit 3 in this number has a value of, okay, so let's underline what she paid, 39 cents. You know what? I'm going to come write that down here in standard form. So she paid $61.39. Okay? And it says what the digit 3. So I'm going to circle that. So what value is this? This is tenths, right? So let's look and see. 10, not 10, right? Because that would be here. So I know it's not that one. It's not ones, so that would be this one. Now I have to decide which one of these is tenths. Well, if I think about my place value, I remember that we have a decimal, and then it was tenths, and then hundredths. So 3 is definitely not over here. So it's not the hundredths, it's the tenths. If I were to read this, 61 39 hundredths. So if I'm looking here, this 3 is in the tenths place. Number 4. Officials recorded the number of visitors entering the Dallas Zoo during a 3-hour period each day for 4 days. So they've given me my information in a chart. They've kind of divided it up for me. So we're looking at Thursday, Friday, Saturday, and Sunday. And then the number of visitors on Thursday, Friday, Saturday, and Sunday. The question asks, which of the following list the days in order from the greatest number of visitors to the least number of visitors? So one thing I could do is I could use a stacking strategy. And I have some space here on this chart. And I notice that I have 4 digits. So I'm just going to make a 4-column chart here. And I'm going to put my digits in this chart. Let's see, I kind of make a little more room just so. So I'm just going to put here ones, tens, hundreds, thousands. So it's not perfect, but it'll get the job done. So Thursday's 768. So we call this the stacking strategy. This works really well, especially for larger numbers. I'm going to move that down a little bit because I think it's kind of giving a glare there. Okay. And then Friday is 1052. So 1052. Then 1934. And 1675. Well, by looking at these numbers right away, I can tell that this is the least because it only has 3 digits. There aren't any. So there are a total of 4 days. So this is the least one. I'm going to put that number at 4. Okay, because I'm going in from greatest to least, right? So now let's find the greatest number. Well, if these all have 1 in the thousands place, then I've got to go to the next place value. So I've got a 0 here, a 900, and a 600. Well, 900 is definitely more. So I know that this is the greatest one. 6 would come next, and then 0 would come last. So if I'm looking at this now, I can take these numbers and kind of write my order here. So greatest would be Saturday, and then comma, and I've just abbreviated it. Second would be Sunday, then Friday, and then Thursday. I guess Thursday's not a popular day for the zoo. Parents are working. So I'm going to find an answer that matches this order that I've come. So Saturday, check. Sunday, no, that says Friday, so that's not right. Thursday, oh no, that's not right because that's the least and it wants it greatest to least. H, Saturday, check. Sunday, check. Friday, check. Thursday, check. Oh, this might be a strong possibility. Let me look down here. Sunday. Oh, no, that's not right. It doesn't even start with the right day. So I know that my answer is H. Alright, so let's look at this one, number 5. The table below shows the population of 5 Texas cities in 2002. So it shows me some cities here, and they're already kind of stacked for me, but it's not asking me to put them in greater than to less than order. So it says name the cities that have populations less than 250,000. Okay, all right, so less than 250,000. So let's look at some of these numbers. So I'm just going to write 250,000 to the side. Whoops, I ran out of paper. Let me write smaller. I'm just going to write this here to the side. I don't know what happened there. Okay. So now I'm just going to compare this to each number and see. So if I look, this has 500,000, and this one only has 2. I'm looking for something that's less. So Fort Worth is definitely not less. So let me write it again, 250,000. So if I'm looking here, okay, they both have 2 in the 100,000, so that means I have to go to the next place value, the 10,000. This only has 1, and this has 5. So Garland is actually less. So that is less than. Alright, so I'm going to go down here, 250,000. So again, I have the same problem. They both have the same 100,000. So I have to go to the next place value, which is the 10,000. This has 7. This one only has 5. So Corpus Christi is actually greater than. So I'm going to put it next. There. Alright, let me look at the next one. Let me write my number again that I'm comparing to. Oh, this one even has more 100,000. So it's kind of like Fort Worth. Nope, that's not going to work. So let's look here. So here we go again, same digit in the 100,000, so both has the same value, but so now we have to go down to the 10,000s. This has 2, and this has 5. Well, 2 is less than 5, so Plano is less than. So you see this test has 3 lines. This question, I shouldn't say test, this question has 3 lines, but if I look here, there's only actually 2 cities. This doesn't necessarily mean that I missed one. It just means that maybe they added an extra line. So I'm going to go back and just double check my work. And yeah, I'm pretty confident that one's more than because it has more. I'm pretty confident this has more because it has more in the 10,000s. And I'm pretty confident that has more because there's more in the 100,000s. So I'm going to go with my answers. I double checked. I'm feeling pretty confident. So I'm going to put Garland and Plano, because remember my question says name the cities. It doesn't want the populations. It wants the cities that have less than 250,000 people living in them. Alright, question number 6. The scout troop is conducting a canned food drive. They need to collect 100 cans to complete the drive. They color one small square below for every can they collect. Oh, okay, so let's see. 1/10, 2/10, 3/10, 4/10. So they have 4/10. 1, 2, 3, 4, 5, 6, 7, 8. So they've collected 48/10, right? Or 48 cans. Don't you think? Yeah, 48 cans. So which decimal shows how many more? Oh, how many more cans they need to collect to complete it. So this isn't asking me how many they've already collected. It's asking how many more. Well, I don't really have to do any subtraction here because the ones that aren't shaded are the ones they still have left to collect. So let's go 1/10, 2/10, 3/10, 4/10, 5/10. 1, 2, 200. They have 52 more to go. So I didn't really have to do any addition or subtraction. So let's look down here. Oh, I see, look at that, 48 hundredths. So, but this is how much they collected, and that's not what the question was asking me, so I'm not going to be fooled by that. Oh, here we have 4 8/10. Oh, I know that that's not right, because remember, this is the whole, right? Oh, look, this one has the same as we did, 52 hundredths more to go. Alright, and then 5, yeah, I know that that's not right, so I'm going to pick H. Alright, 7. Texas has 263,015 square miles of land area. Write this number in words. So let's start slow, okay? 263. So I've just looked at this period right here. 263. Now what was this period called again? These were the ones. These are the thousands, right? So I have 263,000, comma. And then if I look here, 15. So I'm going to write 15. 263,015. Let's move to number 8. Texas has 132 million acres of large farms. How is 132 million written in standard form? Wow. Okay. So 132 million. Well, let me make a place value chart real quick. So I know that I have ones, tens, hundreds in the ones. Then I've got my comma here, and I've got thousands, 10,000s, 100,000s, right? I'm going to put a little thing right here. Here's thousands. And then I know after the thousands comes the millions, so I have millions, 10 millions, 100 millions. Put the millions here. Alright, so I've made myself a little place value chart. It's really quick, right? It's not perfect. So 132 million. Okay, oh, I forgot my comma here. So that's this period, right? So 132 million. Huh, doesn't really tell me about anything down here. But I know that this has to be 132 million. So that must mean that it doesn't have any digits in any of these other place values. But I can't just leave it like that, because if I leave it like this, then it's just 132. So I've got to put those commas in and fill those place values with the digit 0. So here I've written it in standard form, and if you want to write it one more time, you can. Alright, so number 9. In the number below, what digit is in the hundred thousands place? Okay, so these are the ones, period, right? And, you know, I didn't really leave enough room here. So ones, tens, whoops, ones, tens, and hundreds. Then here are the thousands, thousands, 10,000s, 100,000s, right? And then there's the millions. And so this one's asking about 100,000s. Alright, so here's the thousands period. And then the hundreds thousands would be right here. So the 0, that's the digit. Alright, question number 10. It says the shaded models below represent 4 different decimal numbers. Oh gosh. Okay, so let's find out what these decimals are. So let's see. 1/10, 2/10, 3, 5/10. So I'm just going to write it right above here. 5/10. And 1, 2, 3 hundredths. So that's 5,300. Let me move this slide down a little bit. Move this down just a little. Okay. Then I have this one. 1/10, 2/10, 3/10. 4/10 and 1/100. So I have 41/100 here. 1/10, 2/10, 3/10, 4/10, 4 more tenths there. Okay, 4, 2, 3, 4, 5, 6, 7, 8, 48/100. 1, 2, 3, 4, 5/10, and 1, 2, 3, 4, 5, 6/100. So it says, which list shows these decimal numbers in order from least to greatest? Well, if I look at these, kind of the visual helps me out a lot, because I can see right away kind of which one has more and which one has less. But if I want to look at it in a stacking manner, I could. But with the visuals, it's kind of nice. It kind of helps me. So if I'm looking here, which one has the least, I would say to toss up between these two, because they both have 4/10. But this one only has 1/100, and this one has 8/100. And if I think about it like money, 41 cents and 48 cents. Well, 41 cents is less than 48 cents. So I think 41/100 has to go first, my least to greatest. So you know what? Let's write it down here. Comma. And so then I know this has to come next, 48/100. So now I'm left with these two. So they both have 5 in the 10th place, but this has 6/100, and this only has 3. If I think about money again, 53 cents is less than 56 cents. So I have 53/100 and then 56/100. So let's see my answers and see which one matches. Well, that one doesn't match, does it? 41/100, 48/100, 53/100, 56/100. That's a match. 56/100. Oh no. You know what? I can even look and see what they did. These are all my numbers, but backwards. This student, if you choose this answer, that student would have not really read the question. They would have put them in greatest to least. 41/100, 53/100. Oh, wait a minute. No, that's not right, because they missed this one. So my answer would be G. Question 11. The table below shows the population of some different age groups in Texas in the year 2000. So it just shows, here's my age group, 0 to 4, 5 to 9, 10 to 14, 15 to 19. And then here's how many kids there are that are 0 to 4 years. And then 5 to 9. So gosh, that's a lot of numbers, right? Because here I'm looking at numbers, and here I'm looking at numbers. Right, so let's see what the question is. It says, which age group has the greatest number of people? All right, which one has the greatest number of people? Oh, well, I know that population means the number of people. And I'm looking for the greatest one, the largest number. And I love it when they're in charts, because they're kind of doing the stacking strategy for you already, which is great. So if I look at the largest place value, the millions, it's all the same. So I have to go down to the next place value, the 100,000s, and it's all the same. So what do I do now? I got to keep going, right? So now I'm in the 10,000. So if I look here, oh, okay, so it's a little bit different. I've got 2 3s, a 5, and a 2. Now I'm looking for the greatest number. Oh, 5. 5's bigger than 3. 5's bigger than 2. So this is my greatest population. Now if I look at the question, does it want the population? No, it says which age group has the greatest number of people. So here's age group. See that header? 5 to 9 years old. So one of the biggest things about taking a math test, which I know that you know because you've been through 3rd grade and you've been through STAR, is actually reading the question, sometimes even more than once, underlining things that you really want to remember, annotating stuff, right? So here I put like a little star. Can't really see it there, but I put like a little star that shows where my main answer is. It takes a lot of thinking. These aren't questions that you can just go through and not do any work on. Even if you felt really confident about this, to go through and do it, it's probably good practice to go through and annotate and work on these kinds of skills, because it just kind of helps reaffirm and justify your thinking to make sure that you're correct. Alright, let's move on to the last question. The base 10 pieces represent a decimal number. So here I have 2 base 10 hundredths, right? And then I have 3 of these little unit cubes, right? So I need to look here, because this is like a key or a legend, right? Just like in a map. It says the 100 board equals a whole. So whenever you see this, because there are going to be a question on your test like this, that's why I kind of included these, because you rarely want to pay attention to this stuff, okay? This is like the key. So this is saying that one of these is a whole. Alright, so I'm just going to count them out, okay? So I'm going to go 1, 2, and then I have these 3, but these are only just like 3 little pieces in here. And I know those are hundredths. So I have 3 out of 100, right? So I have 3 hundredths, okay? Now, the way I wrote that is really confusing, right? You may go, wait a minute, I don't have 12 and 3 hundredths. No, I don't. I have 1, 2, and 3 hundredths. So I'm just going to write it again so I don't confuse myself. Alright, so it says, what decimal number do these pieces represent? Oh, well, perfect. I kind of already did that thinking. 203. Oh, I see. This person counted each square individually. No, we don't want to do that, because this isn't 100. It's only 1. Gee, 203 tenths. No. 2 and 3 tenths. 2 and 3 hundredths. Bingo. That's what I got. My answer is J. Alright, so I hope this video was helpful for you. I hope to be able to do more videos in the future. Work on my video skills and my nerves. So until next time, good luck.